All right, PKU, which stands for phenylketonuria. Okay, somebody who has PKU, we'd say that they are phenylketonuric is what we would say. But what phenylketonuria means, remember urea has to do with urine. So in these situations, you are going to have an individual that has a phenyl ketone. Okay, we're going to talk about this as phenylacetic acid. So essentially, they have increased levels of a metabolite of phenylalanine that are in their urine. So this is one of those inborn errors of metabolism, so one of those heel sticks that they often check infants for to see whether or not this is a metabolic disorder that they have. About 1 in 12,000 individuals are born with PKU. Well, what is PKU? PKU is basically a malfunctioning enzyme that does the conversion of phenylalanine into tyrosine. So again, phenylalanine hydroxylase is this enzyme. So phenylalanine hydroxylase, or PAH. What we see with so many disease states, right, is you have a malfunctioning enzyme. Big picture thing I want you to remember, malfunctioning enzyme means you are pinching the pathway that's here, which means we are going to be increasing the concentration of anything that's upstream, which means we are going to have elevated levels of phenylalanine, and we are decreasing the concentration of anything that's produced downstream, which in this case means we are having decreased concentrations of tyrosine. Okay, so a way to think about this too, tyrosine is actually not considered, or tyrosine is what we consider conditionally essential here, because we can produce tyrosine, but it's conditional upon us having phenylalanine. So tyrosine here is basically called conditionally essential. Conditionally essential. Okay, because we can make it just fine if we have a functioning PAH enzyme and we have the precursor, we've got phenylalanine. So let's talk about what happens with somebody who has PKU, again, a malfunctioning or faulty PAH enzyme. They're going to have increased levels of phenylalanine. So one thing to remember is that anytime your body has the accumulation of a metabolite that it's not able to get rid of, it often will find an alternative pathway to sort of try to get rid of it. So in this case, what we actually see is the conversion of phenylalanine into phenylacetic acid. So drawing the structure of phenylacetic acid here, basically it's just going to be sort of snipping off that sort of later portion of this. We're not going through the metabolic details for how that happens, but when you generate phenylacetic acid, that actually has a musty smell to it. So individuals who have PKU, if they've consumed excessive amounts of phenylalanine, will actually start having a musty smell, not only in their sweat, but in their urine and things like that, as they are overproducing phenylacetic acid. So a couple of other things to highlight that are complicating factors from having elevated levels of phenylalanine is what we call a large neutral amino acid, or an LNAA. So a large neutral amino acid, right? And you have large neutral amino acid transporters that are going to transport these largely hydrophobic amino acids sort of across lipid bilayers and so forth. So what can happen if you have elevated levels of LNAA, this of phenylalanine, is you're going to saturate these transporters such that other large neutral amino acids like tyrosine can't get it across. So having high concentrations of phenylalanine is you can have your large neutral amino acid transporters are going to become saturated by phenylalanine and unable to transport others. And specifically, we're going to be referring to tyrosine. We're going to see at our next sort of half here why that's important. Okay, elevated levels of phenylalanine we're going to see with people who are PAH deficient, so are phenylketonurics, and we're going to see decreased levels of tyrosine. So here's what we tend to see with people who have insufficient levels of tyrosine. Okay, tyrosine is used to make dopamine. So it's used for dopamine synthesis and both epinephrine and norepinephrine. Okay, so two really important neurotransmitters. And so if we are sort of not having sufficient levels of this, we're certainly going to see some sort of neurological implications there by having insufficient levels of tyrosine. Tyrosine is also an important precursor for melanin. So again, tyrosine insufficiency or deficiency is going to lead to hypopigmentation. So hypopigmentation. Okay, these are going to be in individuals who are going to have pale skin. Now, one of the things that sort of came up as a question in class, this is not specifically referring to vitiligo, which is sort of having patchy areas where you're missing the ability to produce melanin. This is really going to be sort of an overall sort of inability to produce melanin in the body. So with all of our diseases, it's always nice if we try to think about, well, this is what happens. This is sort of the consequence. This is what we're going to see, in terms of symptomology. But can we or how do we treat this? So the solution here is really, and with many of these, is really dietary in origin. So when you think about dietary in origin, you really want to make sure that you are limiting your amount of phenylalanine that you're consuming in your diet. And what that's going to mean is that aspartame is something that you want to avoid. If you don't remember aspartame is the generic name for the trade name artificial sweetener NutraSweet. And NutraSweet basically is a dipeptide between phenylalanine and aspartic acid. It's actually the methyl ester of aspartic acid. But it's not worth that many calories because it's so sweet. You only need microscopic amounts of it in order to trigger the sweet receptors on your tongue. But it's metabolized just like a protein is. And so once you hydrolyze that peptide linkage between those two amino acids, you essentially have free phenylalanine and then the methyl ester of aspartic acid. So you have to metabolize that phenylalanine. Well, if you have PKU, that's going to be challenging. So you normally don't see a lot of phenylalanine in natural products, but if you are consuming a lot of things with the artificial sweetener NutraSweet, also again known as aspartame, you are going to have problems. So you'll see warning labels on anything that contains NutraSweet or aspartame that says phenylketonuria, warning, contains phenylalanine. And that's the reason why. So again, you need to avoid things that contain NutraSweet so that you avoid having sort of an influx of high levels of phenylalanine from that artificial sweetener. But you also want to increase the consumption of food products that are not very rich in phenylalanine. And so those are going to be things like fruits and vegetables. Meats tend to be more rich in phenylalanine. So again, having a more vegetarian or fruit and vegetable focused diet is going to sort of help with that. And always, right, if we pinch a pathway and we have a problem making something downstream, you can supplement with that downstream thing, right? With MTHFR, we talk about the importance of consuming 5-methylfolate so that if you are MTHFR deficient, you don't have to worry about making that bioavailable form. You take the bioavailable form. So again, supplement with Y. So just supplement with that tyrosine that you're going to need. All right, so that's the story of PKU.